Here we are exploring the discriminant of the quadratic equation. So to get us started, let's consider the quadratic formula. So we know that if the quadratic equation ax squared plus bx plus c equals 0, where a, b, and c are real numbers, then we can find x using the following formula. We have that x is equal to minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now, the expression under the square root, b squared minus 4ac, is called the discriminant of the quadratic equation. The value of the discriminant determines the number of real solutions to our quadratic equation. The following three cases help us to determine what type of solutions a quadratic equation will have. So case number 1, if the discriminant is equal to 0, then one real solution exists. Case number 2, if the discriminant is greater than 0, so if it is positive, then two distinct real solutions exist. And case number 3, if the discriminant is less than 0, so if the discriminant is negative, then two distinct imaginary solutions exist. In other words, no real solutions exist. So to help us better understand these three cases of the discriminant for the quadratic equation, let's consider the following examples. Find the discriminant of the following equation and determine what type of solution or solutions exist. And here we are given the beautiful quadratic equation 4x squared minus 12x plus 9 is equal to 0. Now let's recall that to find the discriminant, we must first identify the coefficients for this given expression and then substitute them into the discriminant formula. So looking at our given quadratic equation, we can say that it's of the form ax squared plus bx plus c is equal to 0. So therefore, we can see that the coefficients of this quadratic equation are as follows. We have that a is equal to 4, that b is equal to negative 12, and that c is equal to 9. So now that we have these coefficients, we're ready to calculate the discriminant. So we can say that our discriminant, b squared minus 4ac, is equal to negative 12 squared minus 4 multiplied by 4 times 9. So we have negative 12 squared leaves us with 144 minus 4 times 9 is also equal to 144. So 144 minus 144 is equal to 0. So therefore, since this discriminant is equal to 0, we know that this quadratic equation will have one real solution. So what does this mean? That one real solution exists. Well, let's now take this one step further and actually solve this quadratic equation to find the solution. And then we'll also go ahead and think about what this quadratic equation looks like graphically. So we could use the quadratic formula to solve this quadratic equation, but it's actually going to be faster if we factor. So looking at this quadratic equation, we can factor this expression to the binomial product 2x minus 3 multiplied by 2x minus 3. So we have 2x minus 3 appearing twice. So we can rewrite this as 2x minus 3 squared is equal to 0. So taking this compact form, we can now solve for x by taking the square root of both sides of the equation. So when we take the square root of both sides, the square and the square root cancel each other out on the left, leaving us with 2x minus 3 is equal to 0. So solving this for x, we can add 3 to both sides of the equation. So minus 3 plus 3 cancels itself out to 0. And we're left with 2x is equal to 3. And dividing both sides of this equation by 2, we are left with x is equal to 3 halves, or we can reduce this to 1.5. So we've found one real solution. Now, we also want to keep in mind that a real solution to a quadratic equation may also be referred to as the real zero of the quadratic equation or the x-intercept. So let's take this one step further and write this in the ordered pair form. So we have the x-intercept x0, where we know that x is equal to 3 halves, or 1.5. Now, when we think about the graph of this quadratic equation, we see that the graph of the quadratic function is tangent to the x-axis at the 1 point 3 halves 0. So this graph is confirming the conclusions from our discriminant. Since the discriminant was equal to 0, this quadratic equation has one real solution, as we have verified algebraically and graphically. Find the discriminant of the following equation and determine what type of solution or solutions exist. And here we are given the beautiful quadratic equation, x squared plus 3x plus 4 equals 0. So again, we need to start by identifying the coefficients of this equation and then using those coefficients in our discriminant formula. So looking at this quadratic equation, we can see it's of the form ax squared plus bx plus c is equal to 0. So we can conclude that a is equal to 1, that b is equal to 3, and that c is equal to 4. So plugging these coefficients into our discriminant formula, b squared minus 4 times a times c, we have 3 squared minus 4 multiplied by 1 times 4. So 3 squared gives us 9, minus 4 times 1 times 4 is 16. So 9 minus 16 gives us negative 7, which we can see is less than 0. So since the discriminant is less than 0, we know that two distinct imaginary solutions will exist. Or in other words, no real solutions exist. So to help confirm these conclusions, let's take this one step further and actually solve this quadratic equation. So this time, let's actually use the quadratic formula. So we have minus b plus or minus the square root of b squared minus 4ac, our discriminant, all divided by 2a. So this is going to be equal to, we have minus 3 plus or minus the square root of the discriminant, which we found above to be negative 7, all divided by 2 times 1. So we can simplify this a little bit further. We have negative 3 plus or minus. Now underneath this square root, we can separate this to the product of 7 multiplied by negative 1, all divided by 2. And since we have factored 7, we can now rewrite this as the product of radicals, the square root of 7, multiplied by the square root of negative 1, all over 2. And we know that the square root of negative 1 is the imaginary number, I. So this is equal to negative 3 plus or minus the square root of 7 times I. And that's all divided by 2. So we can see here we have two distinct imaginary solutions. We can rewrite this as x is equal to minus 3 plus the square root of 7 times I divided by 2. And we also have that x is equal to minus 3 minus the square root of 7 times I divided by 2. So these are the two distinct imaginary solutions. And to verify that no real solutions exist, let's think about this graphically. So we can see from this graph that the graph of the quadratic equation never crosses the x-axis, confirming the conclusions of our discriminant. Find the discriminant of the following equation and determine what type of solution or solutions exist. And here we have the quadratic equation, x squared minus 9 is equal to 0. So to rewrite this quadratic equation in the standard form, ax squared plus bx plus c equals 0, we're going to rewrite this as 1 times x squared plus 0 times x minus 9 is equal to 0. So from here, we can see our coefficients are as follows. We have a is equal to 1, b is equal to 0, and c is equal to negative 9. So plugging these coefficients into our discriminant formula, b squared minus 4ac, we have 0 squared minus 4 multiplied by 1 multiplied by negative 9. So 0 squared is 0. We have minus 4 times 1 times negative 9, which leaves us with positive 36. So we're observing that the discriminant is positive. It's greater than 0, which lets us know that two distinct real solutions exist. So to confirm the conclusions of our discriminant, let's now take this one step further and solve this quadratic equation, and then think about what this quadratic equation looks like graphically. So looking at this beautiful quadratic equation, we realize, hey, this is a difference of squares. So we can factor this equation to x minus 3 multiplied by x plus 3 is equal to 0. And we have our two separate cases. We have the case when x minus 3 is equal to 0 and the case when x plus 3 is equal to 0. So case 1, if we add 3 to both sides of the equation, minus 3 plus 3 cancels out to 0, leaving us with x is equal to positive 3. And in case number 2, if we subtract 3 from both sides of the equation, we see that 3 minus 3 cancels out to 0, leaving us with x is equal to negative 3. And we've already confirmed the conclusions of our discriminant. We have two distinct real solutions. Now again, let's keep in mind that these solutions, these real solutions, are also referred to as the real zeros or the x-intercepts. So we can write these two distinct real solutions in the ordered pair form 3, 0 and negative 3, 0. Now, when we think about the graph of this quadratic equation, we can see that the graph is crossing the x-axis at the ordered pair negative 3, 0, and again it's crossing the x-axis at the ordered pair 3, 0, which is confirming the results of our discriminant, that there are two distinct real solutions to this quadratic equation.